Imagine looking up at the night sky. Every bright speck you see is part of a vast, sprawling galaxy. Galaxies are massive systems made up of stars, planets, gas, and dust, all held together by gravity. These cosmic giants come in various shapes and sizes, but they all share the same underlying structure. The Milky Way is the galaxy we call home, but there are billions more out there. There are three main types of galaxies: spiral galaxies, like our Milky Way; elliptical galaxies, which are more spherical and have a smooth, featureless look; and irregular galaxies, which don't fit into either category due to their chaotic structure. The structure of a galaxy is complex. For example, spiral galaxies have arms where stars are formed, and at their center, there's typically a supermassive black hole. These central black holes play a huge role in the galaxy's formation and evolution. After the Big Bang, the universe was filled with hot, dense gas and particles. Over time, these particles began to clump together under the force of gravity, eventually forming the first stars. Galaxies were born from these early clusters of stars. Galaxies grew by merging with others, and as time went on, their structure became more defined. Spiral galaxies, for instance, formed when stars settled into distinct arms, while elliptical galaxies formed from the merger of two or more spiral galaxies. How these galaxies evolved from simple gas clouds into the intricate structures we see today is still a subject of ongoing research. But one thing is clear: galaxies, like the universe itself, are constantly changing. A galaxy's structure is key to understanding its behavior. For example, spiral galaxies have beautiful arms filled with young blue stars, while elliptical galaxies are made up mostly of older stars. The central regions of most galaxies contain supermassive black holes, which are thought to influence their development. The interstellar medium, the gas and dust that fill the spaces between stars, plays a huge role in star formation. In areas rich in gas and dust, new stars are born. These regions also influence the galaxy's overall structure, as gravity pulls matter together and shapes the galaxy's arms, core, and halo. Andromeda, our nearest neighbor, is a spiral galaxy similar to the Milky Way. It's the largest galaxy in the local group, a collection of galaxies that includes the Milky Way, Andromeda, and a few smaller ones. Then there's the Sombrero Galaxy, M104, famous for its distinct shape, resembling a sombrero hat, hence the name. Its large central bulge and surrounding ring of stars and dust give it a unique appearance. And let's not forget about Messier 87, which contains a supermassive black hole at its core. This black hole is one of the largest ever discovered, and it is so powerful that it shoots out jets of energy visible across vast distances. Thanks to powerful telescopes like the Hubble Space Telescope, we've been able to capture images of galaxies millions of light years away. Hubble's observations have given us detailed views of galaxies in all stages of formation, allowing us to study how they evolve. The James Webb Space Telescope, launched recently, promises to expand our understanding even further. Webb's ability to observe the universe in infrared will give us insights into the formation of stars and galaxies from the earliest moments of the universe. One of the most fascinating galaxies in our cosmic neighborhood is Andromeda, also known as M31. Located just 2.5 million light-years away, Andromeda is the largest galaxy in our local group, which includes the Milky Way. But the most exciting aspect of Andromeda isn't just its proximity. It's the inevitable collision with the Milky Way in the future, an event that will reshape both galaxies. In about 4 billion years, the Milky Way and Andromeda will collide and merge into a colossal new galaxy. This process will take hundreds of millions of years and will lead to dramatic changes in both galaxies. While the stars themselves are spaced so far apart that direct collisions are unlikely, the event will cause an incredible transformation. New star formation will ignite. Stars will be sent into new orbits, and possibly even the arrangement of planets in the Milky Way could change. During this process, the two galaxies will gradually pass through one another, causing a transformation of their shapes. The stars will shift to new orbits, and the collision could result in the formation of a giant elliptical galaxy. When the merger is complete, a supermassive black hole at the center of the new galaxy will likely absorb everything in its path, growing even more powerful. While Andromeda is one of the most studied galaxies, many mysteries still remain. One of the most intriguing features is the massive stellar halo surrounding the galaxy, called the Andromeda Halo. This enormous region encircles Andromeda and contains millions of stars and interstellar gas and dust. However, what's truly strange about the Andromeda Halo is that it's unlike anything we've seen around the Milky Way, raising many questions about its origins. Researchers are now exploring whether the stars in this halo might be connected to the supermassive black hole at Andromeda's center, or if the halo could be the remnant of a smaller galaxy that merged with Andromeda long ago. Another mystery is the dark matter deficit observed in the center of Andromeda. While dark matter is thought to be abundant in most galaxies, recent studies have shown that Andromeda may have a smaller concentration of dark matter near its core than expected. Dark matter, the unseen substance that exerts gravitational forces on visible matter, plays a crucial role in holding galaxies together. The absence of dark matter in the core of Andromeda raises significant questions about how galaxies form and evolve, especially when considering the impact of dark matter on the structural integrity of the galaxy. Andromeda's central supermassive black hole is another key feature. Similar to the Milky Way, Andromeda contains a supermassive black hole that weighs about 100 million times the mass of our Sun. However, much like the Milky Way's black hole, it hasn't been as extensively studied. What's particularly interesting is how this black hole interacts with the galaxy around it. Scientists are trying to understand whether this supermassive black hole might be influencing the formation of stars, especially in Andromeda's massive stellar halo, or if it's actively pulling in matter from its surroundings. Thanks to the development of next-generation telescopes, such as the James Webb Space Telescope, we will soon be able to explore Andromeda like never before. The Webb telescope, which observes the universe in infrared wavelengths, will provide deeper insights into Andromeda's star distribution and the activity around its black hole. With this new technology, we can expect to discover more about how Andromeda and other nearby galaxies evolve over time. The collision between the Milky Way and Andromeda will be one of the most spectacular cosmic events in history, and as we study these galaxies, we'll uncover even more mysteries. As our technology advances, we'll likely discover new details about the origin of these galaxies, their star-forming regions, and their supermassive black holes. And while Andromeda's eventual merger with the Milky Way is still billions of years away, the process will undoubtedly reshape the very nature of the universe as we know it. Andromeda is a galaxy filled with unresolved questions, from its stellar halo to its mysterious dark matter deficiency. And as we continue to study it, we'll undoubtedly uncover more of its secrets. These questions will continue to spark our curiosity about how galaxies form, evolve, and interact with each other. And who knows what discoveries await us in the future. As technology advances, we'll be able to study galaxies in even greater detail. The James Webb Space Telescope will soon provide us with unprecedented views of distant galaxies, allowing us to trace their formation and evolution from the earliest moments of the universe. But there's still so much we don't know. Questions about dark matter, black holes, and the role of cosmic collisions in shaping galaxies will continue to drive research for decades. The study of galaxies will not only help us understand the past and present of the universe, but also give us clues about its future. As we look to the stars, we continue to push the boundaries of what we know, uncovering the hidden wonders of our cosmos, one discovery at a time. Galaxies are more than just distant objects in the night sky. They are vast, dynamic systems that evolve over time, with mysteries that continue to captivate us. From the formation of stars and black holes to the ultimate fate of galaxies, there's always something new to learn. As we continue to explore the universe, we uncover not only the secrets of galaxies, but also the story of the cosmos itself.